Okay, the question I chose for my kinematic standard is an archer shoots an arrow at an angle of 22 degrees to the horizontal. At the top of its motion, the arrow just clears the 36-meter high oak tree. How fast was the arrow going when it left the bow? Assume it was shot from a height of 1.0 meters above the ground. How far away is the archer from the tree? So first, if we draw it out, we have the archer, and he's holding it 1 meter above the ground at an angle of 22 degrees. So here's point 1, then here's the tree, so point 2 would be right above the tree, and then the ground that it hits after. So if you write out the 4 kinematic equations we can use to solve this. So first, if you write down everything for the x component, we'll have the acceleration in the x direction is 0 meters per second. The position is 0 meters. The initial velocity is going to be v1 cosine of 22. The position, the second position, we don't know, and the final velocity would be v1 cosine of 22. So for the y component, the acceleration in the y component is going to be negative 9.8 meters per second because of gravity. Position 1 is at 1.0 meters. That's where he's shooting the arrow from. The velocity, the initial velocity would be v1 sine of 22 degrees. The second position would be 36 meters above the ground, and that's given. And then the final velocity would be 0 meters per second, where it stops. So the first part asks how fast was the arrow going when it left the bow. So you can use the kinematic equation for velocity and position, which is v squared equals the initial velocity plus 2 times the acceleration times the change in y. So let's see, we know that it's going to equal 0. So you have the velocity times the sine of 22 squared for this part, plus 2 times the acceleration of negative 9.8 meters per second squared, times the 36 meters minus the 1.0 meters. That's the change in the position. You get, if you solve for v, you get the velocity sine of 22 squared equals 686, and if you solve for v, it'll give you that the arrow is going 70 meters per second. Okay. So for part B, it asks how far away is the archer moving from the tree, or how far away is the archer from the tree. So if you use the equation Vy equals the initial velocity plus the acceleration times the change in time. So this is going to equal to 0. And if you have 70 meters per second times the sine of 22 degrees for this velocity, plus the negative 9.8 times the time, which we don't know. So we have to solve for time. So if we do that, the time is going to equal 2.67 seconds. And that's how far the arrow goes from the archer to the tree. So to find how far away the archer from the tree is, you then have to use the long formula, which is x2 equals xo plus the velocity times the change in time plus 1/2 at squared, the change in time squared, which we know this portion is going to equal to 0. So if you have x squared equals 0 meters plus the 70 meters per second squared from the velocity we found, times the cosine of 22, and that's going to be multiplied by the 2.67 seconds, which is the change in time, minus 0, which will give you a 170 meters. So the archer is 170 meters away from the tree.